Lesson 13.3, linear versus exponential context and models. Number 1 says, which of the contexts below could be modeled by an exponential function? So yes, they're multiple choice. Don't just guess. I see several of you just guessing and then getting them wrong and guessing. Read them, please. It says a population of 100 bacteria triples every hour. Think of what triples means. That means it's going to get 3 times. That is what we're looking for. We want to know something's being multiplied or divided by something. So that immediately I know is called exponential because it's going to grow really fast. Let's read the other one so you know why they're not exponential. So snow is melting at a rate of 2.5 inches per hour. When you have something increasing or decreasing by a common number every hour, every day, every minute, that's going to be a common rise over run or a slope that makes something be linear. So if, let's say my snow started up here, it's going to go down 2.5 inches for 1 hour, down 2.5 for 1 hour, down 2.5 for 1 hour. It makes something linear. So that's why that is not exponential. A music service has a fixed monthly cost, and then it charges 65 cents for each download. So that's like graphing having some cost, and then it's 65 cents per download, 65 cents per download, 65 cents per download. Makes something linear. So that's not. And then a taxi charges a flat fee of 50 cents and then the additional $1.50 per mile. So again, it's going to be the pickup cost of 50 cents and then $1.50 per mile, $1.50 per mile. So all those things mean linear. Number 2, which of the contexts below could not, so make sure you're reading, could not be modeled by an exponential function? A town's population shrinks at a rate of 4.2% every year. So percents are also exponential, just so you know. Percents, because they are a part, they're a ratio, they're a fraction of what they previously were. So percents do count as exponential. So that one is, we're looking for the one that is not. Number 2 is a population of 200 bacteria triples. We've already said that tripling or doubling or quadrupling, that is exponential. The third one, a radioactive compound decays. So it's decreasing at a rate of 10% every hour. There's that percent again. So that's going to be exponential. Should be this last one. A music service has a fixed monthly cost and then charges 75 cents for each downloaded song. That is linear. That's a slope-intercept form problem. Right, and then number 3, which of the contexts below represents exponential decline, or I call it exponential decay? So not just looking for exponential, but which one specifically is decaying. So it would make a graph like this. Population of 100 bacteria quintuples every time. So that's times 5. That's going to grow over time. That's not decay. So it's not that one. Town's population grows. No, we don't want anything growing. An elevator descends at a rate of 18 feet per second. Well, that's descending, but that's a common rate. So it's starting up high somewhere, and it's going down and down, same amount over time. That's linear, so it's not that one. The amount of a certain amount of medication in a person's bloodstream decreases by 1/4 every month. That is a fraction. So that's saying that if it started out at 100, then it's going to go to 1/4 of that, which is 25. Then it would be 1/4 of 25, which would be 25 fourths, on and on and on. It's going to get smaller really quickly. That is our decay. Okay, and then number 4, the approximate number of zombies in a certain city over time is given in the table below. No, I did not make these up. Answer the questions below to explain what kind of function would better model the data, linear or exponential. So on Delta Math, you'll have to drop down these menus and pick the answer, but it says an exponential or linear function would better model the data. It says better, it's not best, but it's better. Look at it. Do you think 34 plus something would make 143, and that same plus something would make 554, and that same number added would make 2,285? Definitely not. This should be exponential. And to figure out what that common ratio is, I'm going to take 143 divided by 34. And so that's about 4.2. I'm going to do the same thing with 554 divided by 143. That's about 3.9, so close. And then I'm going to do 2,285 divided by 554, and that's 4.1. So 4.1. 2,285 divided by 554, and that's 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 4.1. 2,285 So is it the best? But no, but it's better than linear would be. And it says because as x is increasing, the y values change multiplicatively. Yeah, there's a common multiplier or a common ratio. Rounded to the nearest 0.5, the common multiplier of this function is approximately what? Well, what's kind of an average of these things? I would just say like 4.0 or 4.1. Any of that would get you in the ballpark. And that's it.